Hello, my name is Bogdan Kostov. Today I will introduce a small project that I'm working on for converting between different formats of the STPA analysis artifacts to ontology. So maybe before I start, I'll ask if I should speak English or Czech. Anyone has any
Always English. Always English. It's recorded.
Always.
It's always English.
Okay. So I will start by introducing the STPA shortly, what it is, and then I will go into a little bit describing the ontology, and then I will show the current state of the, or discuss the current state of the tool and what are future works. So let's go. So the STPA analysis is a system approach to process hazard analysis. It's a general hazard analysis. It's not specific for safety or security. It could be used for any hazards, financial and so on. And it is based on the idea of a feedback control loop where the hazards are identified through analyzing the system as a control system. So it typically starts from, it's a top-down analysis. So it starts by identifying the system, and I will show that in the next step. This is just the feedback control that it is based on. So we have a controller, a control process. The controller actuates through control actions, and it receives feedback from the control process. And obviously there is this is just one part, and it could be a bigger structure where there is multiple control feedback loops. So there is, from the top, we have a controller, another controller here, another controller here that controls the same process, maybe interaction with processes. And you can see here the different general issues that can occur that the analysis is focusing on. So given that control structure, the STPA process goes through 4 steps, where we first identify the system, we identify the purpose of the analysis. This is the system, and we don't examine things beyond the boundary of the system. And then from this, we identify what are the possible losses, hazards. And then from there, the second step identifies the structure, the control structure. So we identify these control processes and the controllers, and we identify what are the control actions and the feedbacks and so on. So that's the second step. And in the third step, based on these control actions, we identify what are the unsafe control actions, and we identify also how these control actions contribute to hazards. And finally, after this is done, we can refine this hazard from the control action and figure out how this control loop structure contributes to this particular control action. So maybe it's a bad feedback, maybe something else. So in these steps, there is also constraints are identified. So here we identify in the beginning some general constraints for the system in the form of requirements, and then here in the unsafe control actions, controller constraints are defined, and in the final step where the loss scenarios identified, the system level requirements are defined. So this is the process, and it generates the concepts that the analyst defines these individual things that I spoke about so far. And so this, I'm going to transition into explaining a little bit how the ontology, STPA ontology works. So it is based on the stamp ontology to describe the control structure. So here in this diagram, we see the control structure and how we can describe it using the ontology. So we start with the control structure, which has elements, and these elements could be either the components or the connections. So these are the controllers and the control processes, and these are the interactions between them. So is it maybe the feedback or the control action? So the connection is directional, and each connection can have multiple types of interactions. So, for example, a driver is a controller. When the driver drives the car, it can perform different actions like apply the brake, apply gas, the clutch, change the gears, steer, use signaling like blinking and so on. So these are the individual actions that this connection could have, and the same for feedback. So the interaction itself is described through two events, which one starts and one finishes the interaction, and it's performed by the individual parts. So let's say the driver presses the brake and then the car brakes. So these are the two different events. So each control, there is a mistake, I'm sorry, this is supposed to be connected to the unsafe control action, so I will fix that in the final slides. So the control structure, we can, as I said, we can have control action and feedback, and we have to continue with the analysis, we need the unsafe control action, and this is derived from a particular control action and is performed by a specific control structure component. And we have the controller constraint associated with this unsafe control action. And the control action has this, in the analysis, text that describes the control action in detail, which is beyond the STPA analysis. So therefore, it is in text. And what this text has to contain, there is some guidelines, and the text should contain what is the type of the unsafe control action. So there is different ideas of how this should be done, but there are, let's say, 4 standard things where the action is provided or not provided, and that causes some problem. And so that's the first part of the text, and the second part of the text is the context or the situation in which this action is performed. So let's say, just a simple example, when somebody is driving down the road and there is a red light, but the driver applies gas instead of brake. So the situation, so the text would start that the driver applies gas or provides the accelerate action, and the context would be while they're approaching a red light. So again, as I said, this has context is associated here, and the context is containing just the description of the situation, which might be suitable for different control actions. So this is something that it's done if it's possible to be extracted from analysis, if it is provided that if the text has some format that could be parsed. Okay, so that's the control structure, and the STPA analysis really is nothing complicated, because it just has to contain all the other elements of the analysis. So as I said, we have these first step here, we have the loss, the system level hazards, and the constraints. So there are certain, not everything is shown here, but the loss is caused by some hazards. There is a potential for hazards to have parts and so on. So there is a hierarchical structure to hazards. The system level constraints are constraining particular hazard. Then there is the step for the control structure, where we have the components and the structure connection, as shown how they're related in the previous slide. Then the self-control action with its context and the controller constraints. And then in the final step, we have the loss scenario and system level requirement. So this way we can identify if a particular loss is in particular STPA analysis, if we, let's say, have multiple analysis which refer to the same loss. So what is the idea behind the STPA Onto Converter project is that we have different tools that we use to edit, to create a particular analysis or to share it maybe. And different tools have different capabilities. So we need somehow maybe to convert them into an ontology and then try to use that maybe to convert between the different formats, or another thing that it is being used is to validate the ontology, the STPA ontology and the stamp ontology, and to potentially improve it and to see how it could be used in more advanced ways. So what are these tools that we have is the STPA Master Lite, which is an Excel-based tool where there is some features. It's not just plain Excel, it's actually Google Sheets tool. But the format could be transformed into Excel, and then this tool can work with the Excel. So it's not possible to work directly with STPA Master Lite. So the STPA Master is a tool developed by Akin, and it is so the data there is stored in a relational database, and the STPA Onto Converters tool can access database through connection, and it works with a particular version of the database. So if the database changes, unfortunately, the tool has to be updated. But yeah, we could extract this into the ontology. Then there is this these last two are not really capable of performing the STPA analysis, but are only suitable for the second step of the STPA analysis, which is to construct the model for the STPA analysis in terms of the control structure. So what are the controllers, what are the control processes, and what are the interactions between them. So the YET is a simple graph or diagram editing tool. It's focusing just on graph as networks, and the format that is interesting, not interesting, but supported is the GraphML format. But as I say, it supports only the control structure. So this is system control structure. Similarly, SysML is a much more advanced diagram editing software, and it provides sorry, it's not a software, it's a format, but a software using that could describe the model much more detailed than the YED. The YED is very simple. Both of these provide something more than the STPA master and the STPA master Lite, and it provides, like, for example, we can specify hierarchy of components and or a taxonomy, so that there is some sort of taxonomy between the components. So this is why it's interesting to look into those two, as they have limitation in terms of the rest of the STPI analysis. So no first, third, or fourth step. So what the tool can do so far is that STPI Master Lite can import and export to the ontology. Can be imported and exported to the ontology, as I said, though, just through the Excel file. Another thing is that there is, or I'll mention that in the future work. Then for the STPA master is just for importing. Actually, for all of them are just importing to the ontology. And so what is the future work? Well, just to finish with this part, the STPA Master Lite has two formats. One is the one that is the tool, that is the Google Sheets software, which can be exported to Excel and then converted. And it could be exported back to that format. Obviously, it's not going to be the tool, but it's going to look the same way. There is another format for these Excel, and that's from the STPA master. The STPA master allows to export it. The STPA master itself as a software has an export to a format very similar to the STPA master Lite, with a little bit of styling. So that's something that's planned to be done directly for exporting to the STPA master Lite. So it's a similar thing here. Otherwise, what's planned is to implement export for the formats. So to have STPA master ontology to STPA master, and ontology to YED, and ontology to SysML. That last one is probably going to be the very complicated. Another future work is integration with S-Pipes, which is a tool for specifying pipelines, like ETL pipelines, through RDF, and these would be modules where we can include in some pipelines to import analysis or to export, let's say, in the future. So thank you for your time, and if you have any questions.
Yes, thank you. Would it be possible to show the outputs of the transformation or something related to that? Not sure. Probably not now.
Yes, I can try to show something. I planned to have a demo, but live demo, but unfortunately, I have my code base broken right now, not very good state, due to working on S-Pipes, and there are some issues with dependencies, and I have some issue with that. But I can show you some competency questions in the exported ontologies. Or did you mean something else?
Exported ontology. Okay, so maybe go to the slide 2 or 3 where you have yeah, well, this part, this scenarios. So what is exported into the ontology? Everything, right? Like all 4 steps. Do I understand it correctly?
Yeah. Well, it depends on the format. So, for example, for the YED and system ML is just
Yeah, of course.
control structure. For STPA master, okay, that's a good question actually, because previously when I worked on STPA master exporter, it didn't have loss scenarios or requirement, loss system level requirements. I'm not sure, but that part is not implemented. If STPA master already supports this, then that's also something that needs to be extended. But for the light, it converts everything.
Okay, and maybe go to this slide as well. Just show me what should be imported. What could be imported or exported from those tools. So maybe next slide. Yeah. So this means import export to ontology. That was a little bit confusing to me. So import to ontology means you can import Excel into RDF, and export to ontology is the opposite way around. So you can load Excel from the ontology, or what does it mean? Or
Yeah, I'm sorry for this, but yeah, it's importing to the, that means like, okay, yeah, it's converting it to the ontology, the import, and the export is taking the ontology and constructing or creating this Excel file.
and is it a part of this? So is it like one tab, or is it like complete? So you can
No,
take this Excel and use it.
it's the same. Okay, yeah, I will show you. Just give me a moment. So this is so let me just not show something which I'm not supposed to show. I'm thinking maybe for this is okay. And this one. So
Not showing anything, we still see the presentation.
I know. I am opening the files. So this is, thank you. So this is, can you see the Excel?
Yep.
Yes.
Okay, so this is the electrical system which we started this. This is the first thing that I was using. And so it has all of these. This is the first step with the losses, system level hazards and constraints. Then this is the control structure where we have the controllers, the connections, which is in this case, in this version, or maybe in all versions of STPA Master Lite, is just the control actions, and then the controlled processes. Then there are the control, the unsafe control actions with the constraints for the controllers, and then the loss scenarios with its just the loss scenarios and the constraints. So this first step, I don't know why it's separated like this, but yeah, it's these things, and this is something that's exported from STPA Master Lite. So that's the output from converting from STPA Master to ontology, and from ontology to STPA master light. So we have the.
So this is this is what was created from the ontology.
That's created from the ontology. I don't know if I have example for the same analysis, unfortunately.
Okay, so you're basically filling in data into a Excel template, right?
Yep.
Yeah. Okay. Now I understand. Okay. So it's fully functional at the end.
It's not functional. It's just Excel file because the light, the STPA master.
I understand, but with respect to possibilities of Excel, I mean, okay, and maybe just what is this control structure? How much it is the control structure tab? If you can show.
Yep.
I was just not sure here. So this is just. List of controllers and the links. So is it like a full rewrite of the diagram, or is it something that is not expressive? That is the expressivity of this tab the same as expressivity of control structure diagram?
Okay, so
I mean in sense of ontology, not in sense of layout or something like that. But
so no. This is actually exported, the STPA master light allows to construct this part of the step through this the graph ML diagram from the ED software, but it focuses only on the controllers and the processes or the components and the control action. So ignores the feedbacks.
okay.
Actually, new versions also support the feedbacks.
Okay, that's nice. Okay, so sorry, it supports the feedbacks. I don't know then if it supports these information links.
Yes, all the links are supported by the new versions.
Okay, then
Okay, so it's basically equivalent to the picture ignoring layout, right?
right now it should be equivalent. Yes. Well, the new version. Yes.
Okay.
So then this is another thing that could be improved for the converters is that it currently does not. It assumes this is a control action only, so it makes everything into control action.
Okay, thanks.
Then just to show maybe a little bit, this is the analysis, the STPA analysis of the STPA master, and you can see here there is this nesting, and this is something that's experimental right now to import this. So the dashed container is a it's a how to say is a component. So these are parts. So the STPA step 4 is a part, and then there is this other the solid one is a superclass. So these are extending the STPA service, and so these are should be somehow delegated this control and feedback. So each of them should have control and feedback. But this is just some ideas that we're trying to work with.
Okay, so you have two relations between components. One of them is subclass, and another one is part of.
Yep.
Right. Okay.
Yeah. Yeah, and well, the sysml allows for much more expressive definition of the control structure. Yeah, so that's why working on it. Although we currently don't really use the SysML we just have one example of it, and it's more GraphML and the other two.
Yeah, if I may, I have a question. What's the expressivity of the ontology? Can you employ any reasoning in that or not?
It's not designed. I didn't design it in terms of expressivity for now. It's just to represent stuff, but it's based on UFO, and so it should inherit that kind of expressivity, which is not. I think UFO is not decidable.
Yes, because I can also imagine using the ontology for validation, because there are some obvious rules that you can quite easily validate. I think because, for example, you should not be able to do a loop where you have a feedback or control action or whatever going both ways. So between the two components, having control action from the top to the bottom and also from the bottom to the top, and similarly for other kinds of links. Same goes for you shouldn't be able to do control action and feedback between two components going the same way. So I can imagine being able to quite easily validate that using the ontology. I mean, STPA master does validate that, but that's not one that we show.
Yep, I agree. That would be useful. Maybe there could be some constraint for each step that says, or for each of these controllers or control processes, that they are of certain type, and so they have to follow some guidelines. They have to have some control, or yeah, there could be some constraints on them.
So is there any plan to implement those, or what's the future of these tools or of your tool?
Well, for now, as I said, one of the use cases is to kind of try to improve the ontology. So I get data for the ontology, and we can discuss this with Andre, with the guys from the Faculty of Transportation for the competency questions, what they want to know from the STPA analysis. And so for that, we need data, and this way I can fetch data into the ontology. For these constraints and things like that, it really depends on use case. So if I can figure out some use case based on discussion with, let's say, Andre, we can improve that. But I don't really have idea how to do that on my own. And I can think of anything, but I don't know if it would be useful. Maybe this analysis is interesting because it's for the STPA master, so it's something that we understand, as it's a software tool, is not some complicated aviation process that we need to analyze. So I am trying to work on that and create ontology for this, and to go into more detail, and then for the ontology for the aircraft for some other project. But for example, if we can see the control actions, some interesting things is we have CRUD operations very often shown everywhere, but they're structured differently. So for example, there is add loss, system level hazard, and constraint. And then list loss. So here is everything, and here is just list. So it's interesting if we can have ontology and say that this is, we have it like atomic. So we have every CRUD operation, and we can say that this control action has these three things. and things like that. So, and from software perspective, we maybe understand what constraints we can put, or what are the things that can happen from the software perspective, because this analysis was done by non-experts, so they will not be, they are more interested in how they use it than what happens inside.
Okay, that's a good point. But I think the validation also could help with the the gathering of the data that you mentioned.
Yeah, definitely.
The quality of the data, so that you can be sure that the data that you have is usable.
Yes. So one thing is, I believe, problematic, which is related to validation, is if we are really, so we are talking about loss here and we are talking about loss here. So there is no connection between these except from the text. So if we have ontology that's like that, then maybe we can see that there is the add, but there is list, but there is, let's say, no delete. And that could be something that we can notify that the analysis doesn't check the delete for losses and things like that, because it's really not clear whether it covers or it doesn't cover all the CRUD operations. I'm saying CRUD because it seems like it's focusing on that. There are other things, not just the CRUD though. And that's also something that it's often in the contexts, the safe control action descriptions, where they talk about if for any of the actions, or for they're referring to the model, like for example all the CRUD operations, but it's not clear from the text, just the text. So it could be possible that these things would refer to the wrong, that there would be some inconsistency, but this is really more complicated validation as it looks into the text, which is not structured. So yeah, I guess I don't have anything to add to this. So maybe I will contact you, Martin, and ask what kind of validation is done in the STPA master, and maybe I can start from there.
Yeah, sure.
Okay, thanks.
I mean, or maybe you can actually ask Andre, because he should be the one who's able to specify what kinds of control structures are valid and which are not. So we know about these like basic cases, like the exclusiveness of some of the control structure links, but he should be able to give you more complete picture, I think.
So this one that he cannot control back, this one, right?
Yes, for example.
Yeah. Yeah, and maybe last thing, I don't know how this is going to go, but maybe some of it could be part of the STPA master if it's necessary, but it would probably have to be re-implemented somehow. So maybe export to the ontology. I'm not sure if like importing from, I think importing from GraphML works, right? In the STPA master.
Yes.
Yeah. So maybe this one is something that could be But that works as well, I believe.
Well, STPA master does validate all of these like control structure basic rules, I would say. But if you, for example, take just the yet file or the control structure or sysml file, and you STPA master convert it into ontology, there I can also see like the use case for the validation. Also, the STPA master light does not validate these kinds of relationships.
Yeah, sure. Okay, so are there any other questions?
No, I don't think so. So thank you very much.